So next, let's welcome Cesar San Miguel, sorry, from Australia. Cesar is a specialist at the Australian federal government, working on light pollution policy for wildlife within Migratory Species Section. His work since 2020 includes contributing to the development of Australia's national light pollution guidelines for wildlife. Cesar also participated in the Standards Australia Committee for Outdoor Lighting Standards. Today, I will talk about protecting the dark for wildlife, Australia's national light pollution guidelines for wildlife. Welcome, Cesar.
Thanks, Roger. Just let me share my screen.
You are muted.
Can you hear me now?
Yeah.
Hello? Okay.
Yes.
Okay. Apologies. All right. I'll have to pay attention to that while we get going. So I will try that again. Apologies. All right. And you can see that all right?
Yeah, that's great.
Okay, great. Okay, so, it looks like I went the wrong slide. Anyway, hi everyone. I'm Cesar San Miguel. I work in the Migratory Species Section of the Australian Department of Climate Change, Energy, the Environment and Water, and I'll talk a bit about light pollution. Today I'll go over what light pollution is and why it's a problem for most organisms. Next, I'll discuss what the Australian government has done to respond to this threat, and some of the actions we've taken and where we might go in the future. So firstly, almost all life on Earth has evolved over millions of years to be adapted to three different light and dark cycles. The first is the daily cycle of darkness and light over the 24-hour period. The next are lunar cycles, where nights are brighter during the full moon and become darker towards the new moon phase. And the last, third cycle are seasonal cycles. So from longer nights and shorter days in the winter to longer days and shorter nights during the summer. Over evolutionary timescales, organisms that adapted to predictable light-dark cycles have been successful. Diurnal species, like humans, use the night for rest, recovery, and refuge. But, as we all know, there's an entire world of wildlife that have evolved to be active at night. Nocturnal species can use the cover of darkness to undertake important activities and avoid being eaten, like bats. Also, sea turtles, they haul themselves ashore at night to lay their eggs, and their hatchlings then find their way back to the ocean using natural light cues. And again, this is to avoid predation. There's also more cryptic things that happen at night too, like coral spawning, which is tied to phases of the moon. And some fish eggs don't hatch under lit conditions, but instead wait till the conditions are dark. So natural darkness is essential for wildlife and ecosystems. Any man-made changes to the light-dark environment can interfere with and harm living things. Our use of artificial light at night, such as streetcars, boats, homes, commercial buildings, all of this artificial light at night becomes light pollution when it begins to alter the natural patterns of light and dark in ecosystems. So I'll try to get this right. I've got a short animation to share with you all. which should help explain this in a little more entertaining way. So please enjoy.
G'day, Nick. It's me, Maggie from next door. Sorry to bother you, but the kids are trying to sleep and that light is shining right in our home. You know, when we fly in and out of home, the glare from your light makes it really hard for us to focus, let alone get a good night's sleep. Did you know that light pollution can have serious consequences for all kinds of wildlife? Light spillage, like Nick's floodlight, can disrupt reproductive cycles and make it difficult or unsafe for wildlife to go out and search for food. Light clutter is distracting and confusing for wildlife. Sky glow is the distant light glow from a city, making it hard to hide from predators in the dark or see the stars that many of us need to navigate. Artificial light at night is increasing every year, and that means more dangerous impacts for me and my friends. Be a good neighbour. Play your part and help us switch off light pollution together. Thanks, Nick.
Great. So hopefully you can hear me again. Let me know if you can't. Yeah, so light pollution can stall the recovery of threatened species, and it can disrupt important long-distance migrations for migratory species. And further, those individual impacts on species or individuals can cause ecosystem scale changes, impacting interactions between organisms and disrupting processes like pollination, predation, and movement. Oops, oh, there we go. So while light has been great for humans, light pollution imposes serious stress on wildlife and biodiversity, which are already under pressure from things like climate change, land clearing, invasive species, and other threats. Species decline is often death by 1,000 cuts, and light pollution is one of those cuts. Globally, artificial light at night is rapidly increasing by about 2% per year, although this is likely an underestimate. It's been suggested that light pollution may be increasing by about 10% per year. In the US and Europe, it's estimated that around 80% of people can't see the Milky Way. I'd further note that this image on the screen is just a composite of satellite images, and what's seen from space is filtered through the atmosphere and usually only picks up light scattering directly upwards. So light pollution can look very different on the ground, and in many cases is actually much worse. So yeah, light pollution, just for a little more, a little bit of a biology background. I promise I won't go into too much. Many animals have in their eyes rods and cones, which form pictures and of shapes and colors to help them navigate their environment. However, relatively recently, a third type of photoreceptor was discovered in the retina of the mammalian eye, the photosensitive retinal ganglion cell. So these cells don't form any images the way rods and cones do, but instead they trigger biological clocks governing circadian rhythm, and they tend to be most sensitive to blue wavelength light that you get a lot of during the day. Light entering those cells triggers the suppression of the hormone melatonin, providing physiological information to animals about what time of the day it is and how long the day is. All right, that's it. Didn't go into too much detail on that one. Many organisms are, as I mentioned, sensitive to, maybe I haven't mentioned, but many organisms are sensitive to blue light. It's very common, but there's a huge caveat to this. Different wildlife actually perceive light in different ways and have various sensitivities and triggers. We know, for example, that some plants have two different light detection ranges, one for photosynthesis and another for detecting light environment conditions. Plants actually may not thrive under, for example, a longer wavelength red light. So while some species might be sensitive to blue, some plant species might be sensitive to red light. And it's difficult to see in this image, but these black lines represent sort of indicative ranges, just kind of demonstrating the range of nanometers of what species can perceive. And the real point here to take away is that humans can see between 400 and 700 nanometers. So any light that we use to see is likely to be detected by some kind of critter, some species, and may become impacted by it. So yeah, with what wildlife see is still, and how they respond to light is an area with a great deal of uncertainty. And we don't really have a full picture, but we do know that light can impact them. So artificial light, the impacts can include attracting, confusing, or repelling wildlife. So when species like migratory birds or insects are misoriented or attracted to light, it can add to their migration time or travel distance and deplete their energy, leading to exhaustion, poor health, injury, and death. Wildlife can also be disoriented or confused by light sources. For instance, in-water lights at night from jetties and boats are known to cause turtle hatchlings to swim in circles, as the lighting confuses their orientation to the open ocean. And that again can lead to exhaustion and predation. Lastly, light can repel some species from parts of their habitat. Light that repels species from their habitat has basically fragmented or diminished the habitat. And this can reduce access to food, water resources, and interactions with other individuals of the same species. So reducing interactions between species can also harm genetic diversity. It can harm gene flow and reduce the health of a whole population or species. So another impact on wildlife is called masking. Masking means that artificial light at night makes it seem as though it's a different time of day, a different time of month, or a different time of year. Masking can drive physiological changes, such as the hormonal triggers I just mentioned, and that can lead to behavioral change. Light pollution can mask or disrupt the 24-hour day-night cycle, for example, by interfering with sleep in magpies, pigeons, and black swans. It can also delay roost emergence in bats. Artificial light can also mask the subtle light changes of lunar phases, preventing some animals from leaving their refuges during the darker moon phases, so they can undertake important activities like foraging or breeding. Lastly, artificial light can also mask seasonal changes in day length. Exposure to artificial light can cause some songbirds to breed earlier in the year, and can also affect the growth of plants and the timing of flowering, and that can have flow-on effects for other wildlife that rely on those plants for food. A complicated graphic there, but that's available on the government's webpage if you guys want to have a more detailed look. So light can also enhance other threats. It can actually benefit invasive species. So for those of you that don't know, one of the biggest threats to Australia's wildlife are invasive species. Feral cats, as seen here, adapting to the light at night, and foxes benefit from artificially lit hunting grounds. Both are visual predators, and if there's lighting, they have better visibility under the nighttime illumination, even though they've adapted, their eyes have adapted to see and hunt at night. Cane toads and common house geckos can thrive by exploiting insects near artificial light. Invasive birds, like the rainbow lorikeets in Australia, or parts of Australia, may tolerate or even prefer some kind of artificial light. And some invasive plants may be better than natives at exploiting artificial light to grow and spread. And look, nowhere is safe. That's the terrestrial environment, but the marine and aquatic environment is also impacted by artificial light or light pollution. It can really penetrate deep into the water, particularly the shorter wavelength light that many animals are sensitive to. Again, that bluish light. Land-based artificial light can reach corals at depths of over 30 meters. Artificial light from vessels can affect behaviors at over 200 meters below the surface. And in total, around 2 million square kilometers of ocean are now light polluted. And here in the graphic is a small example of zooplankton, which minimize their predation risk by spending daytime in deeper, darker waters and only rise to the surface at night to feed on phytoplankton. In response, many zooplankton predators, such as seals, they undergo their own vertical migrations and adjust their depth of timing of those foraging behaviors to locate prey, which may include both zooplankton and the smaller predators of zooplankton. So something smaller than a seal, but bigger than a zooplankton. Artificial light basically suppresses that upward migration of zooplankton species, and this may disrupt foraging at the water surface for them, and in turn may also impact the movement of those other predators. So in summary, the introduction of light into the environment can be harmful to a range of wildlife in a variety of ways. It can affect behavior and physiology and enhance existing pressures and threats. all of which can have cascading impacts onto ecosystems. And it doesn't take a lot of light to trigger some of these changes, since impacts can occur at very low light levels. So if we want our ecosystems to function well, we need to manage light impacts and protect the dark. So how have we done that here in Australia? To address the challenge, we developed the National Light Pollution Guidelines for Wildlife in 2020, the Australian National Light Pollution Guidelines for Wildlife. The purpose of the light pollution guidelines is first and foremost, as has been mentioned already, to raise awareness of the impact of light on wildlife, as many people do not realize artificial light is a problem for the environment. It's not just a nuisance. They also provide 6 best practice lighting design principles that are applicable to any lighting changes. All 6 should be used together to mitigate impacts, as there's no silver bullet. There's no one way to address light pollution. At least aside from leaving it naturally dark. The guidelines also provide a framework to assess and manage light impacts on wildlife, describing in detail how light should be considered in an environmental impact assessment process and then adaptively managed. The guidelines also lay out information and approaches that intend to bring together, as Fanny just mentioned, lighting experts and biologists who traditionally don't interact. And while there's still a little bit of resistance between these two groups, I'm really optimistic that engineers and wildlife practitioners will continue to increase engagement with each other to find better solutions into the future. There's also taxa-specific advice that can, in the guidelines, with a little more detail for mitigating impacts on specific groups. There's currently taxa-specific advice for sea turtles, migratory shorebirds, seabirds, bats, terrestrial mammals, and ecological communities. So although all this information was developed in the Australian context, the broad technical and practical information contained in the guidelines can be applied in any country or context. We actually presented the guidelines to the United Nations through the Convention on the Conservation of Migratory Species of Wild Animals, or CMS for short. And at the 13th Conference of Parties to CMS, the Australian guidelines were endorsed by member nations and made available as a UN document. And this means that if your country or jurisdiction doesn't have a framework for managing artificial light around wildlife, these guidelines are available for your use. So yes, now what next? What are we doing? Where are we going?
You have 5 minutes.
Thank you. We've promoted awareness among stakeholders so far using social media, events, conferences like this. We've continued to help CMS develop an internationalized version of the guidelines. We made World Migratory Bird Day, the light pollution, the theme for World Migratory Bird Day in 2022. And despite feedback that the guidelines are very long, we published a longer version more recently, but that was before we fully understood how the guidelines were being utilized. However, we did listen, and we've provided comms materials, better comms materials. We've made 5 light pollution animations. We've also put together 1- and 2-page documents with basic information about light pollution, all of which are available on our the government's webpage. We're also engaging with different levels of lighting practice. We've worked with Standards Australia on the environmental considerations in the standard on the control of the obtrusive effects of outdoor lighting, which now currently used to only apply to humans. Now you must consider environmental receivers. We've put $200,000 into some small grants to reduce light pollution for coastal species. We've also consulted with the Green Building Council of Australia, which is a best practice built environment organization on light pollution practices to help inform their new nature credit. We've also been thinking about a complementary approach to light pollution. I'm sure everybody in this room can relate. By that I mean, rather than just focusing on light pollution, the problem, we've been thinking more and more about how to conserve and promote what's already dark. Dark skies have an eco and astrotourism value, as well as a potential cultural heritage value. And I believe 2 years ago, the department, we got our minister to endorse Arkarula Wilderness Sanctuary to become an international dark sky sanctuary, and I believe they reached that status this year, which is great. And now the question is where we're going from here as the federal government. Basically, it's complicated. We've accomplished a lot. It's clear that there's still quite a bit of work to be done. When I first started working in the space, I thought that light pollution would be simple, that you just turn off the light or retrofit the light, problem solved. But unfortunately, it's a wicked problem. There are public safety and security concerns. There's still a lack of perception that more light rather than smarter light is a good thing. There's still a lack of awareness, a lack of comprehension, a complex patchwork of public lighting management and schemes and incentives. And to make matters more complicated, mitigating those light pollution impacts, as I mentioned, it depends on your needs, the landscape, your budget, the species and ecosystem you want to protect. And there's also the backdrop of LEDs, which, while they're more energy efficient, have the potential to be designed smarter. We can actually end up with more light pollution from LEDs if they're not designed well. So from my perspective, the most underserved space is lower level jurisdictions, so states and territories or local governments. There's examples in Australia of the states moving forward on protecting some dark skies. New South Wales in Australia has a dark sky planning guide to protect an astronomical observatory. And Western Australia has recently put out a position statement on dark skies and astrotourism. And so while those address astronomy, they're both, the New South Wales example is a good example of putting effective measures that actually do reduce light pollution. But again, it's often on the ground, local governments that really, I believe, can implement light pollution management practices to a greater effect. And so I think from here, it really is about working closely with them to provide them with more tools and guidance. And that is likely to have a more fruitful pathway towards managing light pollution. And we'll also continue to work with industry stakeholders, lighting designers, engineers, manufacturers. We'll support ongoing research, engage cross-jurisdictionally where possible and appropriate, and consult better with what are considered the world's first astronomers, the First Nations people in Australia. Okay, so I think I got in with time to spare. If you have any questions, let me know. Reach out. There's a QR code that'll take you to our campaign page. And yeah, happy to answer any questions. Thank you so much.
Thank you for your wonderful presentation, and thank you for sharing with us how the light pollution can impact wildlife. So Australia is famous for its wildlife, and I'm glad the federal government view light pollution as a critical threat to the wildlife. And thanks Cesar for his contribution in the national level. I hope it can also happen in many more countries.